the study on processing of substance at nanoscale that are between 1 nanometer to 100 nanometers. So nanoscale is very, very small, and the example of substance are graphene. So graphene, so we will proceed to nanotechnology. Nanotechnology is a development of substance or gadgets using the properties of nanoparticles. So in other words, there are two definitions, nanoscience and nanotechnology. So nanotechnology are related to nanoscience. So nanochemists use the knowledge of nanoparticles to develop substance and gadget using the properties. So as an example is graphene. So graphene is actually a new discovery. The scientists discovered graphene in 2004. And so I know that you don't understand what is actually how small nano is. So this is comparison that I cover. So as an example here, a sheet of paper. So a sheet of paper, you see that the paper are very thin, but it's actually in nanoscale, the paper are 75,000 nanometer thick. So it's a large scale. So the physical and chemical properties of matter change at nanoscale. So how nanochemists are able to see these nanoparticles? So we know that the nanoparticles are very small. So the most recent advancement in microscopy that we use are scanning tunneling microscope and atomic force microscope as an example. So let's see connection between nanoscale and the material around us. So here I want to show you that the nanomaterials actually started from the scale of 10 to the power of -7 meter. And more in 10 to the power of -10 meter. So this is example of nanomaterials such as carbon nanotube and benzene. So we know that graphene sheet is nanoparticles, but actually benzene is a smaller scale of graphene sheet.
Bukan smaller. Maksudnya graphene sheet itu adalah benzin.
Yes.
Okay, dia combine semua tu, tapi dia punya material, dia punya size dia adalah size 0.5 nanometer lah, merujuk pada tu lah. Okay, maknanya dia sangat-sangat kecil dan nipis pun. Okay.
I see. Thank you, sir.
Alright.
Okay, let's proceed to next presenter.
Next,
thank you, Nurin.
We will discuss about the application of technology in daily life.
Ya Allah, siapa seorang romantiknya?
Dia, sir.
Okay, teruskan.
So, as we learned before, nanoparticle sizes ranging from 1 to 100 nanometer, and it is a very small size that enable various applications to be invented. First of all, the most popular is cosmetics, because nanoparticles easily penetrate the skin and provide better UV protection. For example, sunscreen that we use when going outside.
Guna apa kalau tak nak UV masuk dalam kulit apa? Dalam kulit awak guna apa? Sunscreen Chap ke apa?
Nivea.
Alright. So sebenarnya nak cakapnya bahawa kosmetik tu memang menggunakan teknologi nanopartikel. Contohnya to protect UV light kena dekat muka kita. Okay, so kita guna UV light, UV protector lah. Supaya tak adalah nanti muka awak akan jadi sunburn contohnya lah. Alright, teruskan.
Next is semiconductor and electronics. The most recent research effort concentrated on carbon nanotubes and smaller and more efficient semiconductors. Nanoparticle also produce high conductivity wiring system and exhibit exceptionally low electrical resistance. Next is energy and electricity. For example, solar panel, which smaller and more efficient solar cells, and also provide long-lasting batteries. Next is textile. Nanoparticle help develop water, fire, and dirt resistance textile and anti-wrinkle and UV blocking fabrics.
Anti-wrinkle lah, anti-kedut lah. Okay.
Next, nanoparticle is also used in the medical field because, for example, the devices that was used are highly sensitive testing device, and the drug produced is also more effective because the drugs can target the more dangerous cells and not our normal body cells.
Okay, betul, okay.
Next is agriculture. Nanoparticle provide more effective pesticides and highly efficient and through fertilization.
Ejaan fertilization tu salah tu dah.
Oh, yeah. That's right. Nanti kita tahu betul. And finally, is in food production because nanoparticle produce nanoscale food additives and also antimicrobial food packaging.
Okay.
And the packaging can improve the mechanical strength and improve barrier against oxygen, carbon dioxide or UV. Okay, that's all.
Very good lah. Saya suka dengan slide yang application ni. Dia tak perlu kita baca, kita tengok and then kita dah faham dah. Bukanlah maknanya lalu dah. Maksudnya kita tengok tu no need to focus to read word by word tadi. Bagus lah. Mungkin saya nak presentation yang informatif, simple dan informatif dah. Okay, thank you. Habis dah?
Dah. Proceed to next presenter.
Okay, now.
Okay, the next one is the development in field of
5 minutes,
nanotechnology.
Fatia, I give you only 5 minutes.
Okay, sir. The coverage of the field of nanotechnology is very wide, crossing various disciplines including physics, chemistry, biology, medicine, and engineering. As an example, a material that has become one of the main focuses is a carbon derivative that known as graphene. Okay, what is graphene? Graphene is an allotrope of carbon consisting of a single layer of atoms arranged in two-dimensional honeycomb lattice. Graphene is quite hard to separate and insoluble in water due to its strong van der Waals force of attraction. Next one. The size of graphene measures from 0.1 nanometer, makes graphene among the most important materials in nanoscience and nanotechnology. Graphene sheets can be converted into other materials including graphites, carbon nanotubes, and full airing balls.
Itu daripada benzin asal dia adalah asal pada benzin dah. Jadi combine tu dapatlah apa tu graphene Okay.
Okay, the physical properties of graphene. Graphene is an extraordinary material with various distinctive characteristics that can be attributed to its physical properties. The physical properties of graphene is strong and hard, transparent, good conductor of heat and electricity, very low electrical resistance and permeable, which is waterproof, and also elastic. I think that's all for me.
Okay.
Okay, the next one is chemical properties of graphene. So, graphene only form of carbon atoms. Honeycomb is semua honeycomb tu adalah carbon atoms. Next is solid materials, and graphene burns at low temperature compared to graphite. Jadi we need only a liter of carbon atoms. Jadi dia dah burn dah compared to graphite. Graphene juga most reactive form of carbon electrodes. Carbon electrodes ada 3, iaitu diamond, ulleron dalam bentuk ball, lepas tu graphite. Jadi graphite oxide dia use as catalyst. Jadi graphene ni dia ada similar chemical properties with diamond, yang mana dia insoluble dekat dalam water dan organic solvent. Graphene dijumpai pada tahun 2004 oleh saintis Andrejin dan Konstantin Novoselov. Tak silap saya, dia daripada Rusia. Jadi pada 2010 they were awarded the Nobel Prize. So these are the uses of graphene. The first one is polymers and composite. The combination of graphene and polymer produce a durable, long-lasting polymer composite materials resistant to chemical, corrosion, and thermal degradation. Example of polymer and composite is graphene oxide is used in the manufacture of vehicle tires. Next one is energy, where graphene can increase the energy storage capacity and the charge rate of lithium-ion batteries. Such as an example, the lithium-ion batteries that use graphene polymers have a faster charging speed. Next is electronics. Electronics, where graphene can enhance the functionality of touch screen of smartphone and make a faster computer circuits, where graphene flexibility allows the touch screen of a smartphone to be flexed or folded. Next is we need a high surface area. In biomedical, we focus on tissue engineering, where we make a synthetic tissue. And the last one is membrane, water filtration, separate water from gaseous mixture. I think that's all from us. Thank you.
Okay, so very good presentation daripada komputer ni. Okay, benda ni kan awak kena baca je sebenarnya. Baca, insyaAllah awak akan dapat maklumat baru lah. Okay, so thank you, 5 Gamma. Okay, and then